Hello guys, it's Mr. K, and today I'd like to talk to you about how to calculate an empirical formula. So let's start with some definitions. Well, the formula of a compound can be simply determined by experiment. However, the empirical formula is the simplest formula of the compound that you can establish by doing calculations. So I think the best way to explain how to do this is by doing the worked example. So let's look at this question. Analysis of an oxide of copper shows that it contains 3.175 grams of copper and 0.4 grams of oxygen. What is the empirical formula of this compound? Well, there is a series of steps that you need to follow in order to answer a question like that. So, step one, you have to identify the actual elements that you're dealing with in a question. In this case, it's copper and oxygen. Step two, you have to find the masses or percentages or whatever way in which they've given you the numbers associated with these elements. In this case, we're talking about the masses. So we've got copper 3.175 grams, oxygen 0.4 grams. In step three, you start by looking up the periodic table and you look for relative atomic masses of all the elements that you're dealing with here. So in this case, for oxygen it's 16 and for copper it's 63.5. Yes, copper is one of the few elements which doesn't have a full rounded number for its relative atomic mass. Instead, it's 0.5. 63.5 to be exact. And in step 3, you also divide the masses that you've been given in the question by the relative atomic masses that you found out in the periodic table. So as you can see, in this case we have 0.05 for copper, 0.025. Now what do those numbers mean? Well, they essentially mean number of moles, okay? So in step 4, you divide each answer by the smallest. So in this case, we have two numbers, 0.05, 0.025. Clearly, the smaller one is 0.025, so we divide both of them by 0.025, which gives us an answer of 2 for copper and 1 for oxygen. So then you write out the formula. So because the answer for copper was 2, that means 2 atoms of copper. And the answer for oxygen was 1, therefore 1 atom of oxygen. Cu2O, 2 atoms of copper, 1 atom of oxygen. So now that we've done a worked example together, I'd like you to try this example on your own. Calculate the empirical formula for the compound which contains 2.4 grams of carbon and 0.6 grams of hydrogen. So pause this video and give it a go. Alright, so I assume that you've tried this question by now. So again, let's run through the steps. Firstly, we identify the elements, carbon and hydrogen. Then we find the masses that they've given us for each of these in the question. 2.4 grams for carbon, 0.6 grams for hydrogen. Then we look up the relative atomic masses of each of these elements in the periodic table, and we divide the masses that we got in the question by the relative atomic masses. So 2.4 divided by 12 and 0.6 divided by 1, which gives us 0.2 for carbon, 0.6 for hydrogen. Then we divide by the smallest. In this case, there are only 2, so the smaller of the 2, which is 0.2. And that gives us 1 for carbon and 3 for hydrogen. So as you probably would be able to guess by now, it's CH3. Because we got an answer of 1 for carbon, that means 1 atom of carbon. We got an answer of 3 for hydrogen, therefore 3 atoms of hydrogen. So it's pretty straightforward. So in that case, I would like you to try one more example, this time dealing with percentages rather than with masses. So the question is as follows. Analysis of a compound showed that it contained 40% calcium, 12% carbon, 48% oxygen by mass. Calculate the empirical formula of the compound. So pause the video and try this question on your own. Okay, so I assume that you have tried the question on your own by now. So again, let's run through the steps. So first, we identify the symbols for elements that we are dealing with. In this case, we have three elements: calcium, carbon, and oxygen. Then we write the numbers associated with each element from the question. In this case, we've got percentages. So 40 for calcium, 12 for carbon, 48 for oxygen. Then we work out the relative atomic mass by looking them up simply in periodic table. Although carbon and oxygen, you should probably try to memorize these two at least. So we divide the percentages by the relative atomic masses, and we got a pretty nice answer with a full number in each case. 40 divided by 40 for calcium gives us 1, 12 divided by 12 for carbon gives us 1, 48 divided by 16 for oxygen gives us 3. So we should divide by the smallest. However, in this case there is no point because dividing by 1 simply does not change anything. So if you divide 1 by 1, it's still 1. If you divide 3 by 1, it's still 1. So what we know is that there must be 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen. So we got CaCO3. Alright, so I hope that helped you a little bit in understanding how to work out the formulas and how to calculate them using this simple method. And I wish you all the best and see you in my next videos. Bye.